Alright guys, we are back with another episode of Elias's Practical Sciences. So before we start fully, I would say you guys to go to my hit the like button and click on the bell notification icon to get notified for my next content. Alright, so today we're going to be talking about logistic regression. So first of all, let's define what logistic regression is. Alright, so logistic regression, this is a relationship between an independent variable and a dependent variable, whereby the dependent variable gives us a result of a binary classification. So this simply means that our predicted values are going to be in a binary format, which is of the form 0 and 1, which is of course the output, the way a computer actually reads values. So as a programmer, every time you type code, the computer doesn't necessarily understand what you're typing. It takes the work of the compiler in the case of Java and C++, or the work of the interpreter to be able to interpret your code into binaries. But this algorithm, called the logistic regression algorithm, allows us to give a binary classification as a result. So the algorithm is such that it allows you to predict either a yes or a no, a male or a female, whether it allows you to predict if someone has cancer or not. That is what I mean by binary classification. So when you plot a graph on the results, that is, when you plot a graph to get a relationship between the dependent and independent variable, you get a sigmoid function. So a sigmoid function, the name is just gotten because of the shape it forms. It forms like an S when you plot a graph. So I will show you the diagram how it looks like. So this is how the graph is expected to look like. Alright, let me zoom in. Okay, so zooming in, so you can see the graph here that I drew just to show you what I'm talking about. So the sigmoid function, so you see it forms an S. So we can even plot the graph before we get down to our data set and try and predict values if we're going to get a male or a female. So you can see that here, this is my data set for the height, this is my data set for the weight, and this is the data set for the calorie burn. Now the weight, the reason why you can see that I have a single digit for the weight is because the weight is measured in kilograms and I've divided each weight by 10. That's why, so this person's original weight was 67 kilograms. I divided it by 10. That's why we have 6.7. And these are the gender results. You can see, so now in my case, I made 1 to represent the male gender and I made 0 to represent the female gender. It doesn't matter. You can decide to do it the other way around, but just make sure that your data sets also match the binary classification. Alright, so before we get down to it, so I'll quickly show you how you can plot a sigmoid graph so that you could see what it looks like. So the first thing I'm going to do, I'm going to import a library called the matplot library in Python. So now this library allows us to be able to plot a graph, but of course we cannot plot a graph or else we import the pyplot submodule from it. Alright, so I've imported it. Now the next thing I'm going to do, I'm going to get two values. So I'll have x. I'm just freestyling to show you how the graph will look like. Plotting against 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so I'm going to plot it against the y-axis. So I'll say y is equal to, alright, so we're going to start from 0. It's going to be from 1 at 0, going up 6, 7, 8. Alright, so I'll start from 0. I'll say 0, 0, 0, 0, 0, 5, 1, 1, 1, 1, 1. So this is what we're going to get. So we said the predicted outcome is binary classification. So now I will just say plt.plot. I'm plotting my x-axis against my y-axis. Just trying to show you what I mean by binary classification and the sigmoid function. Alright, so I'll quickly plot that graph down. I will plot it quickly. Well, we might not get exactly an S, but we'll get something similar to that. So you can see the sigmoid function, so whereby the data set of the X. So in our case, so you can see that from our logistic regression, we have multiple independent variables. So if I go back to my picture, you can see I have multiple X's. I have X1, X2, X3. But this is the dependent variable. So this is the variable that we are trying to get as a result of the independent variables. Alright, so this is just a little overview of what we are expected to get. So you can see it's a sigmoid function. But with the irregularities with our points, it might not be exactly like this, but this is what we're expected to get. Anyway, let's get down to it. So now we know what logistic regression is. I think without further ado, I'm going to start writing our code. So like I said, before you start or before you go ahead with this video, I would appreciate it if you hit the like button and if you subscribe to my channel and turn on the bell notification icon. It's really going to help me. I'm really going to I really need you guys likes and subscription so that I can be encouraged to create more content like this. Alright, so let's start. So I'm going to create a class. And I'm going to call it logistic. So logistic, my class. Alright, so before I continue, I'm going to import the matplot library and the numpy library so that we can plot our graph. So import matplot live.pyplot as plt. Alright, so imported that. And the next thing we're trying to do is to create our initializer. And of course, we're not creating any variable inside the initializer. Alright, so my book for my data points, alright, so that I will not lose track of it. So we're going to have our height, self.height. I haven't seen anyone who memorizes data points before, but there are people who do that. A waste of time anyway. So I have my 1.73, 1.70, I have my 1.71, I have my 1.72, 1.70, 1.5, 1.62. I have to be fast because my battery is low anyway. 60, 1.61, 1.62, 1.60, 1.61, 1.63, 1.63, 1.73, 1.83. Alright, so just to be sure, we're supposed to have 12 data points for our height. Alright, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, so I have that. So I have not imported numpy. Import numpy. I don't know why this is taking so much time. It's supposed to predict. Alright, thank you. So that's the IntelliSense. Before you are done typing a value, it predicts what you're going to type. Alright, so you have self.weight. Oh, now that's new. Alright, sorry about that. Array. Alright. Array. So I have 6.723, 6.521, 6.521, 6.631, 6.631, 6.721, 6.721, 6.521, 6.512, not 21. Alright, 6.001, 5.412, 5.4, 5.412, 5.178, alright, 5.178. 5.217, 5.421, 6.801, 001, 5.5410. These are my values for my weights. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright. The next one is going to be the calorie burned. The calories burned by each gender. So now we know that 1 represents the males and 0 represents the females. Alright, so let's get back to it. So the next one is going to be my self.calorie. I'll just call it self.calories as my numpy.array. Let me check my battery percent. It's kind of low. Alright, so let's continue. So calories 3.742, 3.742, 3.611, 3.6117, 3.6117, 3.6781, 3.6781, 3.6992, 3.6010, 3.6010, 3.2312, 3.2312, 3.0210, 3.0010, 2.9729, 7219, 3.781, 781, 3.8171, 3.1211. Alright, so we have our values. So these are all our x. Our x1, I can just put x1 beside it so that I can know it's x2. Okay, so something I didn't mention is that the logistic regression algorithm uses the multiple regression underneath. So it uses the multiple regression under the hood. But before we continue, let us get our self.gender. So we know that. So now this will not be a numpy array. This will not be a numpy array. So just make it a list. So just say 1, 1, 5 ones, 2, 3, 4, 5, and 5 zeros, 1, 2, 3, 4, 5, which represents the females. Then we'll have a male, and we'll have a female. Alright, we're done. Alright, so now I want to create our algorithm, but okay, so we have, just call it regress, and we're going to get some future values because we will need to predict future values, height, weight, and calorie. Alright, so they don't have any values yet. So now our B0, our B1, and our B2 and B3, they are all going to have initial values of 0. So I'll have 0.0, my B2 is equal to 0.0, and my B3 is equal to 0.0. Alright, now rates. Alright, so rates is, this tells us the learning rate of our algorithm. So it tells us the rate at which our algorithm learns to predict new values, or how our algorithm can become so accurate so as for us to use it to be able to predict future outcomes. So this is just the rate at which the algorithm learns. Alright, so that's for learning rate. And the next one we have is epochs. So this tells us the number of times we can train our algorithm to make it accurate. So now I make mine 5,000, so my algorithm is going to run 5,000 times. So the more time you give your algorithm to learn, the more accurate it will get. So in data science and machine learning, our algorithm becomes more accurate when you train it more. That is, depending on the number of times you train it for, and it also gets accurate when you give it more data. So these are the two instances whereby our algorithm can get more accurate. Alright, so we're going to use a for loop that would allow us to repeat a process so that we can use it as a way to train our algorithm. So I'll say for I in range of epochs. So like we said, epochs represent our learning rate. So I can just print out each epoch at each iteration. So I'll just say str. So str is a function that allows us to convert numerics to strings. So I'll say my I, because my I at that point is a numeric value. Alright. Then I'll create a nested for loop. I'll be explaining this in my subsequent Python videos. But for now, let's just use it. Alright, I'll just give you a heads up anyway. Coming. Let me write it down. Next. itex1. Alright. So now what happens with for loops is that this for loop is going to run completely. What I'm saying is that I'm looping through the length of the self.height x1 array. So this is going to loop through all the elements because we have 12 elements. It's going to loop through them, every single one of them. Then it's going to move to the next iteration in the first for loop here. So the first for loop would start, which is the first value in 5000, which is 1. So we're going to run through this entire loop from the first value to the last, then start the outside for loop again, switching to 2, then run this one again completely, switch to the next one, 3, run this again completely. So that is how nested for loops work. Alright, so now since we said that our logistic regression equation uses multiple regression, we're going to say b0 plus b1 plus multiplied. What are we multiplying it by? So I'm multiplying it by the self.height. I don't want to scroll up again so that we won't waste time. But this time around, we are looping through each element within the range. So I said j represents an element in the length of my height. So at this point in time, now the length of that list is 12. So j represents 1 because we have 12 values there. Hope you understand. This length just simply means 12. I could as well clean this length self.height x and just write 12 there. And j will represent from 1 or from 0 down to 11. So at this point in time, height of x at the 0 index, I'm going to substitute the value and get the output value. Alright, let me just type it so that we can follow along. So b2 multiplied by self.weight weight of j plus b3. So our b3 is also 0 as well, multiplied by self dot x3 of j. That's for the output. So after we have gotten the output, I'm going to get the predicted value, which is going to be 1 divided by 1 plus exponential. So now we need to import our math module. Let's check if we imported that. So you want to import the math module. So this is a special module that allows us to use mathematical equations in our Python program. So you can just say math dot exponential. So exponential allows us is an Euler number that takes the power. So this is the standard Euler value. So which is our exponential. So which is going to be the inverse of our output. So that is what I'm going to have. Then after that, I'm going to find the new value of our b0, which is equal to the old value plus rate at which the algorithm learns multiplied by the y. So my y is my self dot height. That is my y. My y is my self. No, sorry. My y is going to be my gender. So I'll just say self dot gender y. So we are going to be multiplying it by the gender. So you just say self dot gender y, but I'm going to start from the very first value and multiply all through last. So multiplied by, so minus the predicted value. So minus the predicted value and multiplied by the predicted value and multiplied by 1 minus the predicted value and multiplied by 1. This is my B naught. So for our B1, it's going to almost be the same thing. So rate multiplied by self dot gender. I'm multiplying everything by the gender y, starting from the very first value minus the predicted value, then multiplied by predicted value, then multiplied by 1 minus predicted value. And this time around, we're going to multiply it by the first value, because B1 here, if you look at our output equation, we multiplied B1 by self dot height x1. So I'm going to put self dot height x1 there. Self dot height x1 at the j index as well. So you do the same thing. So instead of me typing the same equation over and over again, I'll paste it 2 more times, and this one is going to be my weight x2 of j with x2, while this one would be my calories x3. Alright, so now I'll just change them to B2 and B3. B2. B3. Alright, so now let us print out each coefficient. So of course we already know from my previous videos that B0, B1, B2 are our coefficients. Alright, so I would say print B0, I'll do the same thing, string B0, then B1 as well, then B2 plus string B2, then last one B3. So we also want to print out the predicted value as well. So predict going to be what? Alright, so that's our value. So now this is going to keep on running continuously till we have gotten the result. This will run continuously till we get the result. Alright. So after we have gotten our new values, because this is going to give us the final values for B0, B1, B2, and B3 and the predicted value, we are now going to substitute that into our new equation to get the newly predicted values. So now I'll write output again. So output is equal to my, alright, so what I'll do, I'll just copy it out since I've written it already. So this equation was one of our shortest anyway. It will soon be done. So I'll just copy it out and put it there. Okay, it's going to be the same thing anyway. But instead of myself, I'm going to put something there. Something different. So just clear all this. I'm no longer working with the previous initial values. I'm going to be working with height, my coefficients. That is my parameters I created. I would be explaining what parameters are in my subsequent videos. on Python. So gender, I don't know why this is not working. Okay, so did I create a gender variable? So let's check our function. Calorie gender. So calorie, which is our x3. So calorie. Alright. This is our output. So the output, we are going to get the predicted value, a new predicted value, which is going to be 1 divided by 1 plus maths, of course, dot exponential, then minus the output. Alright, so we can also print out the predicted value. The print predicted value. Can print it out. Then we can create an if conditional statement. That if the predicted value is less than or equal to 0.6, so if we predict 0.6, because we're trying to get binary classification that goes within the range of 0 to 1. Now from 0 to 0.6, we are going to predict a female, but from 0.7 upwards, we are going to predict a male. So we would say if we predict a female, print predicted a female. But you can create an else or an elif in Python. The elif predicts is greater than 0.6. So just say print predicted female. Have our values complete. Alright, so let us try to predict future values first before we plot the sigmoid graph. Alright, so the name of my class was Logistic. So I'm going to write it down there. I'll just say logistic class dot regress, if I'm not mistaken. So we're going to try to predict new values. So what if someone has a height of 172 meters and he has a weight of or the person has a weight of 6.812 kilograms and burns calories of 3.6211. What would be the person's gender? So now we're trying to give our algorithm to learn. So I said my learning rate is 5,000. So my algorithm is going to learn this 5,000 times. So give it time to run. Alright, so it says no attribute with X. Alright, so I made a mistake in my code. Let's go back and correct it. Line 35. All these things are bound to happen in programming, but I was rushing, so there. So it's x2, okay, so this is that. Alright, let's see the next error. Alright, okay, no error. So now my algorithm is being trained. We're training the algorithm to see if it's going to predict a male or a female. Let's give it time to run. So it's going to run 5,000 times. It's training the model. Rather, we are training the model to give us prediction if that person is a male or a female, which is a simple logistic regression. Alright, we're still waiting, still training the model. Let's just wait for it. $5,000 is a lot of time. Alright, should be done. done by now. Okay. So you see, it gave us a prediction of 0.8, which was very close to what we actually predicted. So we said a binary classification of from 0 to 1, whereby if we have values that lies within 0 to 0.6, we predicted a female, but if we have values greater than 0.6, we predicted a male. So, and if you can see from our previous equation, when we had our 1, 0, 1 and everything, you could see that 1 represented the male and 0 represented the female. Alright, so let us try to plot our graph. Let's try to plot our graph. But before we can do that, we'll have to rewrite this equation again. So we'll have to rewrite the equation again. Alright, so what I'll do anyway, I'll use this, just like I said, it's a logistic, or it's a logistic regression. So you can plot either of these values, our height against the gender. So let us try to take one of these our values, but this time around we would have to switch a value back, that is start from 1 or from 0, whichever way you choose to start from. So we can start from 0 to 1, that is taking it, flipping its side, or rather flipping it backwards. Alright, so what I'll do, I'll comment this out, the predicted value, so that we can see how the graph would look. Alright, let me check my battery. Yes. No. Alright, so I have my PLT plot. Alright, but before that, I'll just create new values for my Y. Create new value for my Y. To save ourselves stress, I'll just copy this down, copy it, then paste it here. So we might not get a perfect sigmoid, but we're going to get something very close to that anyway, because like I said, sigmoid arranges itself from the lowest value to the highest value in an ascending order. So if your values are scattered, that is, your values on the X, if they are scattered, you're not going to have the exact diagram you are looking for. Like I said, the name was coined from the shape of the diagram on the graph. So let's use height so that we can see value. Copy this down, paste it here outside. Right, so delete this as well. So you can see that my 1 matches with this. So what I'll do, I'll try to put it in an ascending order. So to say, try to put it in an ascending order. So I'll just remove this guy from here, 1.73, and add it somewhere here, 1.73. Okay, so I have 1.65. So the highest value to the smallest. Anyway, this one is supposed to come before the other, so I'll just copy it, rather cut it, Ctrl X, and put it here, Ctrl V. Okay, Ctrl V, so that I can just have my badge properly. So I have 165, 162, 160. Okay, so let us make it in an ascending order, like I said. So now these two, right, so I'll just remove these two from here. I'm wasting time, but I'm just trying to show you what the sigmoid function looks like. Okay, I'll just remove it from here, this is somewhere here. Alright, I'll change this one to 162, 165, so that we can see how the sigmoid function looks like. So 170 and 173, 170 171, 173. Alright, we have two 173s. I'll make it 172. Make this one. And I'll add a 1.73. So make sure we have 12 values as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, yeah. Have an extra value here. Alright, so this one 171. Alright, so now for the values here, since I have my ones here, I will just cut them from here on the works, place them after this value here on the V. Then I will move and one more so that we can have our 6 complete. We have 6 values, 1, 2, 3, 1, 2, 3. So let's try to plot them. I'll just say height x1 against my gender y. After that, let's try to show build it to show. Let's see how I use that. Let's try to plot graph. So that's how we have our sigmoid function. So it was not exactly the way it was initially when we started the program and the video, but you can see that now we have something that looks similar to what we plotted initially. So this is how the sigmoid function is. So please, if you have enjoyed this video, please subscribe to my channel, hit the like button and turn off that bell notification icon. My name is Eliazar and you are watching Eliazar's Practical.